Hello and welcome. Today, we are going to solve an interesting geometry-oaked problem that looks difficult at first, but once we start solving it, you'll see it's actually quite easy. So, let's start by drawing a right-angled triangle. From its base, we'll draw a perpendicular line going straight up to meet the hypotenuse. Now, from the point where this perpendicular line meets the base, we'll draw another line connecting all the way up to the apex of the triangle. In this way, we have formed three triangles inside our big triangle. But we are giving that the area of the left triangle is equal to 6 square units, and the area of the middle triangle is equal to 2 square units. Is this possible for us to find the area of the whole triangle? Now, if you want to try this problem for yourself, you can pause the video right now, and then come back to check the solution. Now, let's label the vertices of our big triangle as A, B, and C. Next, we label the intersection point between the perpendicular and the base as D, and the intersection point between the perpendicular and the hypotenuse as E. Now, look at the right triangle ADC. We can label the base as A, and its height as B. So the area of triangle ADC equals A times the height B over 2. Since we know its area equals 6, A times B over 2 equals 6. By simplification, it equals A times B equal 12. Now, look at triangle DEC. Here, DC is the base. Let's label it as C, and AD represent the height of this triangle, which equals A. So we can say that the area of triangle DEC equals C times A over 2, since we know that its area of this triangle equals 2. So C times A over 2 equals 2. By simplification, it equals C times A equal 4. Now, from the first equation, we can conclude that A must be equal to 12 divided by B, and from the second equation, we conclude that A is equal to 4 divided by C. Since both of these equations are equal to A, this means that 12 over B must be equal to 4 over C. Now we can work through this. We can cross-multiply 12 times C equals 4 times B, dividing both sides by 4B, and we get C over B equals 12 over 4, which simplifies to 3. Oh wait, let me recalculate that. If 12C equals 4B, then dividing both sides by 12B, we get C over B equals 4 over 12. And by simplification, it equals 1 over 3. So we can conclude that C over B equals to 1 over 3, or, in simple words, the ratio of C to B is 1 to 3. Now let's use an interesting property of similar triangles. This property states that if we have two similar triangles, the ratio of their corresponding sides can be calculated, but it can also be calculated as the square root of the ratio of their areas. We're going to use this fact in our favor. Let's first take a look at the right triangle DBE, and we're going to label its area as A. Now, let's identify which triangles are similar. We can look at our big triangle ABC, and we can also look at the small triangle DBE. We know that both of these triangles are right triangles. We can also see that both of them share the same angle at point B. So since these two triangles have two congruent angles, this means that those two triangles are similar. Furthermore, we know that the area of our big triangle ABC is equal to the sum of the areas of our three triangles, which equal A plus 6 plus 2, giving us A plus 8. And the area of the small triangle DBE is equal to A. Now, we use the property of similar triangles which we mentioned earlier. We can say that the ratio of their corresponding sides is equal to the square root of the ratio of their areas. So C over B equals the square root of A over A plus 8. And we already know that c over b equals 1 over 3. So we can substitute this value. This gives us 1 over 3 equals the square root of a over a plus 8. Now, we simplify this equation by squaring both sides. From this, we get 1 over 9 equals a over a plus 8. Now, by cross-multiplied, we get that 1 times the quantity a plus 8 equals 9 times a. This simplifies to a plus 8 equals 9a. Subtracting a from both sides, and we get 8 equals 8a. From this, we will find that the area of our small triangle DBE must be equal to 1 square unit. Now, it's pretty easy to find the area of the whole triangle, since the area is equal to the sum of the areas of all 3 triangles inside it. So the area of the big triangle is equal to 1 plus 6 plus 2, which equals 9 square units. And that is our final answer. Thanks for watching. If you found this helpful, don't forget to hit the like button and subscribe for more